Good morning everyone, myself Deepak and I am doing my MSc in chemistry from IIT Tirupati. So today we will discuss a very important topic from the JEE points of view and also from the NEET point of view, that is the concentration term. We do not discuss the definitions of this, we discuss two basic concentration term via the question. And this is the question asking JEE 2020 and this is a very nice question. What is the statement of the question? The statement of the question is like this: a solution of two components. So it means this solution is made up of how many components? Two components containing N1 moles of first component and N2 moles of second component is prepared. So it means a solution is just prepared of the two component 1 and 2. The number of moles of those components are given, that is N1 and N2. M1 and M2 are the molecular weights of the component 1 and 2 and their molecular weight is also given. If D is the density, this D is the density of the solution in gram per ml. C2 is the molarity and X2 is the mole fraction of the second component. So it means this C represents the molarity and X represents the mole fraction and this 2 is used for the second component. Then C2 can be expressed as, so it means we have to represent or we have to find out the value of this concentration term for the second component. Now when we go through the option, this concentration term and this molarity is represented as in term of mole fraction or the molecular weights. B option is also there is mole fraction and molecular weight and same for the C and D. So basically in this question we have to represent or we have to establish a relationship between the molarity and the mole fraction of that component. How we can approach this question from the very basic definition? So basically we have to find out the molarity. So firstly write the definition of molarity. As we know, the molarity is molarity here it is represented by C and 2 is used for the second component. Molarity basically represents how many number of moles is present in 1 liter of solution. So how we can write the molarity? This is the ratio of, or we can say the number of moles of second component, divided by volume of solution, So in the definition we just write the number of moles present in 1 liter of solution. If this volume of solution is given in ml, then this should be multiplied by the 1000. This is the basic definition of the molarity, number of moles present in 1 liter of solution. So to find the molarity we need the two things. One is the number of moles and second one is the volume of the solution. And the number of moles of the second component is already given in the statement, this one. This is the number of moles of the second component. Therefore number of moles of second component that we need already given in the question, that is equal to N2. So next task is to find out the volume of the solution. How we can find out the volume of the solution? We can find out the volume of the solution by using the density, because density of the solution is that nothing but the ratio of mass of solution to the volume of solution. So by using the density of solution is equal to mass of solution divided by volume of solution. So what is our task? To find out the volume. So how we can find out the volume? Therefore volume of solution is equal to mass of solution divided by density of solution. And this is given in gram per ml. Therefore what should be the unit of this volume? The volume has the unit of ml. So from this we want to find out the volume, but we know the density. So next task is to find out the mass of the solution. How we can find out the mass of the solution? As we know, the mass of solution, what should be the mass of solution? The mass of solution should be equal to the mass of its component present in that solution, that is mass of component 1 and mass of component 2. Therefore mass of solution is equal to mass of first component plus mass of second component. But no direct mass is given. How we can find out the mass? Basically, there are two terms is given. One is the moles and second one is the molecular weight. And there is a relationship between number of moles and the amount of substance and the molecular mass. And what is that? The number of moles of any component we can find out if we know that is the mass of substance, yeah, amount of that substance, divided by its molecular weight, or nothing, we can say that this is molar mass. So how we can find out the amount of mass? This is nothing but the number of moles into its molecular weight. So we can write here mass of solution is equal to mass of first component is what? This is the number of moles of the first component into its molar mass. That is equal to number of moles of the first component is M1. And what is the molecular weight of the first component? That is M1. Therefore M1. Plus, for the second component in the same way, number of moles into molar mass. What is the number of moles of the second component? That is N2. And what is the molecular weight? That is M2. Therefore we can write N2 into N2. So, if we know this mass of solution, but none of the options have this type of arrangement, we can say. So we have to rearrange this one. How we can? Because there is no N1 and N2 in the expression. So, but numerator have N2. How I will know? Because the number of moles of the second component is N2. Therefore, there should be N2. But there is no N2 in the option. So it means we have to convert this N1 in term of N2 also, so that we can take out the common and this will cancel out. How we can do this? From the definition of mole fraction, because mole fraction is given here. Mole fraction is represented by X, and this represents nothing but mole fraction. Fraction is represented how much part of that component is present, and this is represented by the ratio. Therefore, mole fraction is the ratio of the moles of what? If we use for the second component, then the number of moles of the second component, that is N2, and divided by the total number of moles present in the solution. And what is the total number of moles of the solution is present? That is N1 plus N2. N1 plus N2. By using this relationship, we can find out the value of N1. How? Therefore, this N2 is equal to X2 into N1 plus X2 into N2. We just take out here, then N2 minus of X2 into N2 is equal to X2 into N1. Take N2 as a common, N2 1 minus of X2, therefore this is X2 into N1, and therefore N1 is equal to N2 into 1 minus of X2 divided by X2. So this is the value of N1. By using this relationship, we can just solve this mass of solution. We have to put this value of N1 into this expression so that we can find out the mass of the solution in term of N2 and X2. Why? Because all the options have either mole fraction and the molecular weight. So the mass of solution. So the mass of solution is written as, that is N1 into M1 plus N2 into M2. We have to put the value of N1. Therefore, N2 divided by X2 into 1 minus of X2, and this should be multiplied by M1. Therefore, into M1 plus N2 into M2. So this is the expression. From there, we can take N2 as a common and X2 also as a common. So when we write this N2 divided by X2, this sum is equal to 1 minus of X2 into M1, because N2 by X2 is taken as common, plus from here N2 is taken as common but 1 upon X2, therefore this is multiplied by X2 into M2. When we simplify this equation, this is equal to N2 divided by X2, we multiply by M1, therefore this is M1 minus of M1 into X2 plus x2 into m2. Now n2 divided by x2, this is now, we can take x2 as a common, therefore m1 plus x2 as a common, then this become n2 minus of m1, like this. So this is the mass of the solution. This is mass of solution. Now what our task is to find out the volume. Therefore volume of solution is equal to mass of solution, that is n2 divided by x2, m1 plus x2 into m2 minus of m1, and this is divided by density, and this is D. And D has the unit of gram per ml. Therefore what is the unit of this? The unit is ml. So now we know the number of moles, we know the volume of the solution, now we can find out the molarity. Therefore molarity of second component, that is C2, is equal to number of moles. What is the number of moles of the second component? That is N2, and divided by the volume of the solution, that is N2 into M1 plus X2, M2 minus of M1, and now this D into X2 is in the numerator, D into X2, and this is in ml, therefore this should be multiplied by the 1000. Now, and this N2 will cancel out this N2. What will be the final result? The final result is equal to 1000 into D into X2 divided by M1 plus X2 M2 minus of, so this will be the final result. Now we just match it with our options. So this is matched with the option. This is 1000 into x2 divided by, but there is no D, therefore this is not our option. D into x2, no 1000 is here. D into x, 1000 into D into x2 divided by m1 plus x2 into this one. From here, we can also eliminate the two options from here. How? Because the density is given in the gram per ml. Therefore, by using this relationship, we find out the volume. Then volume should be in ml. If volume is in ml, then the formula should have the 1000. So in the option 1 there is 1000, but in option B there is no 1000. In option D also there is no 1000. Therefore, these two options we can eliminate from here. So our option should be either A or C. Out of these, when we do this complete calculation, we find that the relationship between this molarity for the second component and the mole fraction of the second component is like this. I hope you will get this one. Thank you and have a nice day.